what object is moving and in what direction. Today, we are going to look at how to solve this problem. A 5.0 kilogram box is pushed across a frictionless floor with a constant horizontal force of 20 newtons. What is the acceleration of the box? Let's look at the solution. The first thing to do in solving Newton's second law problems is to first establish your coordinate system. Cartesian coordinate system is nothing but vertical axis, which we call the y-axis. So any vector that points upward is going to be positive, and then any vector that points downwards is going to be negative. Also, we should have the horizontal axis. So we have any vector that points to the right is going to be positive, that is positive x, and then any vector that points to the left is going to be negative x. The second step is to look from the problem what information we are given. So in that case, we call it the data that is given to us in this problem. So the data given is that the mass of this block is 5.0 kilograms, and then force of friction is 0 because the floor is frictionless. It means that there's no force of friction between the bottom surface of the block and also the floor. Also, what is the amount of force pushing this box on the horizontal floor? And that is the applied force. In this case, I'll call it uppercase F, and that is equal to 20 newtons. So these are all the information we are given, and we are asked to determine the acceleration of the block. So what we need to apply here is the Newton's second law, which says that the acceleration of a block or an object, which is a vector quantity, right? So it has to have both magnitude and direction, should be equal to the net force acting on the block. This summation sign means that we are summing all the forces on the block in a specified direction. And that is the reason why you need to have your coordinate system. So if we are dealing with the horizontal component of the force, we consider the horizontal axis, which is the x-axis. If we are considering the vertical component of the motion, then we focus on the vertical axis. So back to our Newton's second law, it says that the acceleration is equal to the net force acting on the object divided by the mass of the object. So this is Newton's second law. So our task here is to determine this acceleration. However, if you look at this problem, this block is not moving vertically because it is just pushed horizontally along the frictionless floor. Straight away, we can say that the net force along the y-axis is equal to 0. And what are these forces? Here we can see that there's the weight of this block acting vertically downwards, which is mg, and there's also going to be the normal force acting vertically upwards, which is Fn. So the net force, that is the sum of all these vertical forces along the y direction, is going to be Fn. You can see that it is pointing upwards, so it is positive per our coordinate system, and then minus mg, which is the weight of this block, equal to 0. We can say that the normal force is equal to the weight of this block. So that is for the vertical component, and we can see that the net force is equal to 0, meaning there is no acceleration. So now let's focus on the horizontal component because that is where the motion is happening. In solving Newton's second law, always ask what object is moving and in what direction. Some problems may require you to do the law in both direction, which in the next video or so, I'm going to discuss similar problems like that. But for now, we can see that the net force along the vertical direction, along the y direction, is 0 because this block is not moving vertically. It is only moving across the horizontal floor, which is due to the force of 20 newtons applied to this block. In that case, if we do the Newton's second law, the net forces along the x-axis should be equal to the mass of the block times the acceleration. With this, we can isolate the acceleration as we've seen here. The acceleration is nothing but the net force divided by the mass, right? So to do that, we can say A is equal to the net force. We have this force pointing to the right, so along the positive x-axis, F, and then friction always opposes the motion, so minus, so it opposes the motion, meaning it points in the negative x direction, so minus Fr, and then divided by the mass of this block. And this numerator, F minus Fr, is the net force. Okay, so the net force here, that is, we've summed all the forces acting on this block in the horizontal direction. If we plug in the values, we are going to get the acceleration to be equal to, so our F, which is positive to the right, 20 newtons, and then minus the force of friction, right? So friction force always opposes the motion. In this case, the floor is frictionless, so that is equal to 0. So 20 newtons minus 0, and then divided by the mass of the block, which is 5.0 kilograms. All right, so now we can simplify this as acceleration is equal to 20 newtons, and 1 newton is 1 newton is equal to 1 kilogram meters per second squared. So here we can have that. So kilogram meters per second squared, and that is divided by 5 kilograms. So simplifying this is going to give us an acceleration of A equals 20 divided by 5, which will be 4. And then in units, we have this kilogram cancels this kilogram, and we are left with meters per second squared. So we have meters per second squared. And this is the unit for acceleration. So acceleration is equal to 4 meters per second squared. It is positive because the net force is going to produce this acceleration of the box to the right. Per our coordinate system, this box is going to accelerate, meaning it is going to speed up in the right direction, that is in the positive x direction.